A good day to you all. Today's Liceo Math Club tutorial will be about the definition of a derivative of a function at a given number. The derivative of a function is one of the basic concepts of math, and together with the integral, it occupies a central place in calculus. The process of finding a derivative is called differentiation, while the inverse operation is called integration, but we will not deal with that right now because we will try to deal with the derivative of a function at a certain point. Now, the derivative of a function at some point characterizes the rate of change at this point. Now, we can calculate the rate of change by calculating the ratio of the change in vertical positions to the change in the horizontal positions, or let's say delta y all over delta x. As you probably know, this is the slope formula that some of you have already learned back in junior high school. Now, in the definition of a derivative, this ratio is considered in the limit as delta x approaches 0. Let's turn to a more rigorous formation. Now, this is a formal definition of a derivative. Any function f of x whose domain includes an open interval at some point of x sub 0. You see, x sub 0 will be any point. May it be any point on a line. Then the function f of x is said to be differentiable, meaning you can take the derivative. And it is given by this function. F of x sub 0 is equal to the limit as x sub 0 approaches 0 of the function delta y over delta x. And if we expand the definition of delta y, given 2 points, let us say we will describe it as the limit as delta x approaches 0, f of x sub 0 plus delta x minus the original function f of x sub 0 all over delta x. Now, this is the notation and how we write the derivative. Now, let's start with Lagrange's notation. This notation is denoted by f prime or y prime. So basically, you just add the y prime to the f to the function. So if you're looking for the derivative of this function f of x, its derivative will equal f prime of x. With Leibniz notation, it will be this definition. The derivative of y equals f of x is equal to dy over dx. Or if we can rewrite it in other terms, we can say d over dx f of x. Simple. Now, here are the steps to find the derivative of a function at any point as follows. Let's say that point is x sub 0. Now we have to form this difference quotient. And if we try to simplify it, we need to cancel out the delta x, because if we try to substitute it, we will get an indeterminate answer. Now, here's what we will do. We are going to find the derivative f prime of x sub 0, and we're going to apply our limit laws. If this limit exists, we can say that this function is differentiable at x sub 0. And using the derivative, let's prove that the derivative of a constant is 0. Here's how we will do it. Let's say that a constant is equal to c. So let us try to derive delta y. Now, it will be equal to x plus delta x minus the original function. So basically, you're just subtracting a constant by a constant. So you know why is that? Because because a constant will occupy a straight line, a straight horizontal line, so there is no rate of change. Hence, the derivative of a constant is always 0. As you can see in this example, we can actually prove that the derivative of a constant just by setting c equal to x. Let's try to calculate this derivative, y equals x. Here, we can see that the x terms will cancel out and we're simply left with 1. Hence, this is Hence, the derivative of y equals x equals y prime equals 1. So, this is actually, we'll try to get into a more generalized form if you have a variable. Here's this next example. Let's calculate the increment of this function. So we'll try to expand, we'll have to try to expand the term with the delta x. So if we expand these and collect like terms, we get that as delta x approaches 0, the derivative of this function is 2x plus 2. So basically, you are trying to do the long method. In the next tutorial, you'll be learning how to deal with, you're gonna learn how to deal with derivative rules. And now let's try this. We're going to introduce this rule. Now, if we try to expand the terms with the delta x there, we'll see that the derivative of this function is 3x squared as the limit of f of x approaching 0. Now, here's what you can notice. In the original function, it is x cubed, and in the derived function, it is 3x squared. I think you might notice that there is a pattern here. And that concludes our Liceo math tutorials for today. Thank you for listening to our tutorials. We hope that you've learned something, and I'm pretty sure that you have a good insight on what the derivative is about. Thank you so much, and animo la Salle.